All right, 8th grade, video 3 of lesson 8.2. We're going to pick up with addition of subtraction, but now we're going to have polynomials involved where it's not just properties of exponents. We are going to actually need to factor. Okay, so here we have for guided practice 3A, I don't have much I need to factor. In fact, all I need to factor are my denominators. Okay, so factors of -6 that add to -1 are -3 and a +2. My second fraction, all I can do is take out a 5. Okay, now that I'm completely factored, I need to look for that least common denominator. Well, I see a 5, I see an x minus 3, and here's where I see an x plus 2. Even though they both have an x plus 2, at most you only have them once in each fraction. So you only want to include it once in your least common denominator. Or you can think, what do I need to do to each fraction to make the denominators the same? So in this case here, I'm missing a 5 that my second fraction has, but my first does not. So I'm going to multiply numerator and denominator by 5. Notice I put the x minus 1 in parentheses. That way I can see very clearly that I'm going to end up distributing. And then for my second fraction, I have a 5 and an x plus 2, but I don't have an x minus 3 like the first fraction does. So I'm going to multiply top and bottom by x minus 3. Okay, so now I'm going to clean that up. My 5 times x minus 1, and then my least common denominator. And then here I have a 4 times x minus 3 with my least common denominator. Okay, and I have a note here. The order doesn't matter in how you write your parentheses as long as they're the same. Okay, and then now that I have that least common denominator, I can bring my numerator together with subtraction. So here's where I mentioned in video 2 that you want to simplify your numerator because there's a lot happening here, and when we simplify, we might end up being able to cancel some more out. Okay, but we want to leave the denominators factored. Never touch the denominators once you factor them. So I'm going to distribute 5x minus 5, negative 4x plus 12. Combine my like terms. I end up with x plus 7. No common factors with the denominator. I'm completely simplified in the numerator, so now I'm done. Okay, I have a couple more notes here. We already addressed this one. Always simplify the numerator. Be careful with subtraction. You will subtract all terms in the second fraction. So for example, here, it's not just minus 4x. It's minus 4x minus 4 times -3. So make sure you carry that subtraction sign through. So here's an example that I came up with. When here we have two fractions we're subtracting, they have common denominators already. This is not the same thing as just sticking the negative sign in between and rewriting the numerators. You're subtracting everything in that second fraction. So this is actually how it would work. So you're going to subtract the 4 minus a in the second fraction. So you want to put those in parentheses so you don't mix up your signs. Okay, so that's something to watch out for. It didn't really happen here because we had that 4 with it, so it might help you catch that. But whenever you have just a subtraction sign with no distributive property, technically you are still going to distribute. You're going to distribute that subtraction sign. Okay, so that wraps up 3A. Let's take a look at 3B. So for this one, again, we need to factor, but we only need to factor the denominators. This is, I didn't show the work for it, but this is where we have to do a little bit of that lengthier factoring where you do factors of 4 times 5 that add to 21. So that factoring by grouping. If you need to refresh that, that's going to be back in chapter 4, I believe, lesson 3. Okay, so factors of 20 that add to 21, group, and then factor. Okay, my second fraction here, I can take a 3 out, and I'm left with 4x plus 1 on the inside. Oh, and there's a note, so it is lesson 4.3 that you'll review how to factor this one here. Okay, so when we create our least common denominator, for the coefficients, I have a 3. I have a 4x plus 1 in both fractions, so I only need to include it once, and I have an x plus 5. Or again, you can think, what does each fraction have that the others does not? So here we have a 4x plus 1 and an x plus 5, but we don't have the 3 that this one does. okay, with our least common denominator. So I'm going to multiply the top and bottom by 3. The second fraction is missing an x plus 5, so I'll multiply the top and the bottom by an x plus 5. So I brought it together. As you get comfortable with these, you might not have to write this step here. You might be able to go straight to this step where you have it written out in a better form, but don't do that until you're ready. Excuse me. Okay, so now this is addition. So the note that we talked about with example 3 part A with subtraction, that doesn't matter here because you're not going to have to mess with any subtractions, distributing negatives. This is just simple addition. So instead, I'm just going to go ahead and distribute each and put a plus sign in between. So 3x minus 8 plus 6x plus 5. And that's where I get my numerator here. Oh, sorry. There we go. Okay. Do not multiply through your denominator. Extra work you don't need. Combine your like terms, 3x and 6x and negative 24 and 30, and we stop, well, we don't stop there, but we simplify down to that. Now this is the case where if you can factor in this final step with your numerator, you want to do so to check to see if there's anything else you can take out. Okay, so the 9x plus 6, and that's what this is telling you here, they're both divisible by 3. Okay, so if you were to stop here, you did the addition correctly, you just didn't completely simplify. Okay, so here we end up with, if we factor a 3 out of the numerator, we're left with 3x plus 2 inside the parentheses, and you can see that we have 3's that would cancel out. Okay, so this value, this expression here and my boxed-in expression are equal expressions. This is accurate in terms of adding the two fractions. It is not completely simplified. So if I were to grade this on a quiz or a test, you'd lose a point for not simplifying your answer. Okay, so don't get super hung up on that right away. If you go and you start checking answers and you're getting something that might look completely different in the numerator and something's missing in the denominator, that means you could keep going. It doesn't mean you're wrong, it just means you're not done. So that's what this is telling you here. Before boxing in final answers, check to see if you can factor the numerator, then see if there's a common factor with the denominator. So another example here, kind of going rogue here, but say I did all my addition, I came down, I got this answer, and I stopped there. I'm technically not done. I can take a 3 out of both of these terms. So I would end up with 3 times, and then in parentheses, x plus 3. And in this case, an actual binomial factor cancels out. And this would be the simplified answers. So you must have completely simplified answers when you go to submit tests and quizzes. Okay, but take it in steps. Again, if you're checking your answer, notice how in this answer your numerator looks completely different. Your denominator is missing a factor. That's a key right there. That is a hint that you need to keep going. Okay, so that wraps up lesson 2 notes. These ones honestly just take practice to get you more comfortable. If this video did not help, or if any of the 3 videos did not help, please email me and I can help you further.